Okay, in this video we're looking at how industry and equilibrium are tied together. So in industry they talk about the yield, how much they make. So the yield is how much of the reactants you turn into the product that you want for industrial reasons to sell on to another company or to make something. So here we've got the old classic, the whole process. We want to increase the yield of NH3, ammonia. Now theoretically, look at what we've looked at before, a high pressure would increase the yield because we have 4 moles of gas here and 2 here. So if we increase the pressure, the position of equilibrium will move to the side with fewer moles of gas, which in this case will be to the right. So we get more products, higher yield. Excellent. Low temperatures as well would increase the yield because we've got here delta H is minus 92. So going to the right is the exothermic direction. So if you decrease the temperature, position of equilibrium will move in the exothermic direction, which in this case is to the right, and so we get more products, higher yield. Okay, so that's theoretically what we want to do if we want to increase the yield. But there's other things to consider. If you have high pressure, yes, that increases the yield, and it also increases the rate of reaction too, because we saw when the pressure increases, you have more molecules in the same volume, so you have more collisions, collision theory, faster rate of reaction, more successful collisions frequently. Okay, so that's good too. Fast rate, high yield, excellent. But an important thing to know about pressure is that it needs a lot of energy to increase the pressure, running costs. So if you've got a plant running 24 hours a day, all day, you've got a lot of energy being used to run some sort of industrial sized pump to make that pressure, which is expensive. And also there's safety concerns. If there's a leak, there's some sort of problem, if it's under pressure, it's a lot more serious. Okay, so the safety concerns and the safety of the workers have to be considered. Okay, low temperature. Yes, low temperature gives you a high yield, moves the position of equilibrium to the right, but it would decrease the rate of reaction. It would make the rate of reaction go slower. Okay, because a lot of the molecules then will not have energy above the activation energy needed for the reaction to occur. So your rate will be a lot slower. So it's all very well and good having a high yield, but if it takes a very, very long time to make it, then that's not obviously going to be industrially favourable. So we have what we call compromise conditions. We use a temperature between 400 and 500 degrees centigrade. That gives the right balance between the yield, so which way the position of equilibrium is going, and the rate of reaction. Along with that, we use an ion catalyst because a catalyst lowers the activation energy, so we don't have to go to as high temperatures for the reaction to occur, which will favour the yield. Okay, and pressures, we use about 200 atmospheres, so that's high but not so high that it's dangerous. So these are compromises to get the balance between safety, yield and rates. Okay, so it's not all simply just looking at it theoretically.